All right, data store. Only 103 slides. That's 30 minutes. We have 20 seconds a slide. You ready? Dun, 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 dun. All right, we'll go a little bit slower. So data store is a NoSQL database, which primarily means you have no joins across tables. And it generally means it's less flexible. It's not as powerful as what you can do with queries. But if you don't need that power, it's a good solution, right? And so it also, the benefit is it scales really well. So you could do, with SQL databases, you could do a lot of complex, like, hey, this user, this account, different tables get data and get one result. And but that has a performance cost. Like if you're doing that like thousands of times a minute, I don't know, millions of times a minute, that's going to totally bog your system down. So you can't do that kind of stuff with NoSQL, but NoSQL you could do things really fast, right? Because it doesn't have that performance thing of costly joins. So NoSQL scales really well. And generally speaking, a lot of stuff you don't need to do complex joins. If you do have to sort of like, like I want to see all of the users who posted, had posts today. Well, I have one table, maybe, let me think of another example. But you can do one query and then get the results, and from those results, do another query, right? And that could sort of approximate what a join would do.
So like if you were looking for the birthdays of all the users who posted videos today, one table has user birthday, another one has user video, then you look at all the ones that posted videos, take those names, and look at the other one.
Yeah, right. Instead of doing it in one operation as you would in SQL, maybe do it in two operations with NoSQL. So this is going to be our primary database in App Engine. And it's schemaless, so if you hear that phrase, that means you do not have to define ahead of time what your table looks like. You don't have to think about what fields will be in each table. You don't have to beforehand think of your entire data structure. Your database can evolve and change on the fly. All right. So,
and then the scaling really well means it can get really, really big. NoSQL databases are a lot easier than SQL databases to split across multiple machines. So when you get big enough that it can't all fit on one machine anymore, Google can easily split it up into multiple things without much of a performance cost or anything, which is difficult to do with SQL.
I think I damaged my brain from not sleeping enough. I'm looking for fifth gear, and I'm having a hard time getting it into third. So here's the translation between SQL and how you think about SQL data structures and NoSQL. Right? So SQL, you think about tables, records, and fields. And in NoSQL, you think about kinds, entities, and properties. And those, I thought maybe I had arrows, but those kind of translate across, right? So I might have a table called employees in SQL. In NoSQL, I'd have a kind employee, right? I might have records in SQL, each employee. So I'd have Corey, I'd have Eunice, I'd have Daniel, right? Those would be records. Over here, these would be entities, right? And I'd have fields in SQL. These would be properties. So when you hear the terminology, that's kind of how it translates. That's the easiest way that I've found to think about it. And you notice I dropped off the S's here because, hey, here's a table, right? Or it's a kind, it's employee. Oh, here's a record. Oh, it's an entity. It's E1, E2, employee 1, employee 2, employee 3, right? And here are the fields, or the properties, name, role, hire date, account. And so what that translates to when we start to do stuff with the data store, we have our kind, our entity, our properties, and I left table record fields there just so you could start translating that in your head. And kind is kind of like a type in Go, right? So we could have, if it's an employee, we could have a type struct or type employee with an underlying type of struct, right? And so the employee would translate to the kind, right? And we could have an entity, which is like a variable of a type. So here's E1, and that's what we just did. And then we could have the properties, which are like the values, right? And so here we have those values, and that's what those properties are. So that's kind of how, right, you kind of think about like, how does it go from NoSQL to Go code? Your kinds are kind of like your types or a struct, right? And then your entities are, you know, like a variable of that type, and then your properties are the values. So some of the verbiage from the docs on App Engine and NoSQL data store, right? In Go, data store entities are created from struct values. Data store entities are created from struct values. The structure's fields become the properties of the entity. To create a new entity, you set up the value you wish to store, create a key, and pass them both the data store put. Updating an existing entity is a matter of performing another put using the same key. To retrieve an entity from the data store, you first set up a value into which the entity will be unmarshaled, then pass a key and a pointer to that value to data store get. So to create, set up the value. So create a value of type struct, right? Create a key and use data store put to pass the value and key to the data store. So I'm not doing any of that right there. And to retrieve, you set up a value, create a value of type struct, use data store get, and pass a key and value pointer to data store get. So we'll see that in action.
Hopefully, at least.
Eventually. You can query based on properties, too. So give me all the employees who have the role manager, right? So that's something else you could do. There's rats in the attic here, too. Objects in the data store are known as entities. An entity has one or more named properties, each of which can have one or more values. Property values can belong to a variety of data types, including integers, floating point numbers, strings, dates, and binary data, among other things. A query on a property with multiple value tests whether any of the values meet the query criteria. This makes such properties useful for membership testing. And then it talks about schemaless here. Unlike traditional relational databases, a data store does not require that all entities of a given kind have the same properties, or that all of an entity's values for a given property be of the same data type. If a formal schema is needed, the application itself is responsible for ensuring that entities conform to it. So keys, creating keys. A lot of reading. Finally, code. All right. Each data store entity is a particular kind. So how's it go? Kind, and then what? Entity, and then what? Properties. So each data store entity is a particular kind, which categorizes the entity for the purpose of queries. For instance, human resources application might represent each employee at a company with an entity of kind employee. In addition, each entity has its own key, which uniquely identifies it. The key consists of the following components. So each entity has its own key, and the key is made up of the entity's kind, an identifier, which can either be a key name string or an integer ID. So the kind and then some sort of an identifier make up the key. And you could also have an ancestor path locating the entity within the data store hierarchy. The identifier is assigned when the entity is created. Identifier is assigned when the entity is created. Because it's part of the entity's key, it's associated permanently with the entity and cannot be changed. It can be assigned in either two ways. Your application can specify its own key name string for the entity. You can have the data store automatically assign the entity an integer numeric ID. So when you create a key, your application can specify its own key, or you could have the data store automatically assign some key. So here's type key, and you have new incomplete key and you have new key. A new incomplete key is you're letting App Engine provide the unique key, right? Like, it's not complete, you finish it for me. You put in the unique ID. And with new key, you're providing the unique key. So you could see in each of these we're giving a context. And then a kind, this is kind string, kind. And then we have a string, and so kind is also string here. Kind and string are both string, right? And then we have string or int, and this is where you're passing in a unique ID. So I might say, hey, I'm going to have email be, the user's email be the unique ID, and I could pass that in, and that'll be, right, the unique ID for accessing stuff. And then here, if we have a parent key, we can pass that in, and then it returns a pointer to a key. So this, it takes a little bit to wrap your head around, but so here's a type employee struct, and we create a new context, and then we create a variable of type employee with these values, and then data store put, right? And we're getting a key back here, so we're putting in the context data store new incomplete key, right? So with put, we pass in a context, we pass in a key, and then we pass in what we're wanting to put. So where did we see did we see any documentation for how put works?
No.
I don't think we've seen that yet. Do I have it here? Kind of interested in seeing it. So where do I go to see the documentation for App Engine? For me, I just do go App Engine, and then come in here. Oh, there's Data Store, and then go to Storing Data, Data Store, and Reference, and then come down here, and I have all this stuff, my index, and I'm looking for put.
Near the top.
So there's put, and put takes the context, a key, and interface. Put saves the entity source into the data store with key K. Right? Source must be a struct pointer or implement property load saver, so a struct pointer. So over here, we have context, key, and then what we want to store, struct pointer. So we're putting that new incomplete key. So incomplete key, we pass in context, kind. The kind, what is kind? It's kind of like your tables, right? It's like, hey, this is going to belong to this group. Just like, hey, this entry is going to belong to this table. Like I have an employee table, now I'm going to put in an employee record. So here's the employee record, right? Here I have an employee kind, and I'm going to put in, what's it called? Kind entity. Kind entity property. And then, so I put it. And then I could do var e2 employee, data store get, and get's going to take a context, a key, and then I need some sort of data structure to receive it. And so here var e2 employee, so variable e2 is of type employee. So I now have that. What does var do? It initializes to its 0 value, right? So that's all initialized to the 0 value. So right now, if I was to look at e2.name, it'd be an empty string, right? So that'd be the 0 value is of a string is empty string. So I get it, I put it into E2. If there's an error, I deal with that. And then store to retrieve employee named, and then I bring out E2 name. So that's it for putting and getting.
So we're getting this key here from the return value of put. Put will return the completed key. So if you gave it a full new key where you specified the identifier, it's just giving back that. But if you pass it in an incomplete key or whatever, then put will be at that time grabbing it. When it gets the ID, put will send back the actual completed keys that you can use to look it up again later.
Question?
Yeah.
Your use of var to make the employee struct. Does it create all 4 members of the struct with, you said, the default?
Yeah, the 0 value.
What about the time? What is that default? 0, 0, 0, 0?
Yeah, the 0. I think the 0 time usually is somewhere in the 1980s or something.
Okay.
Because in most computers use Unix time, where it's basically counting the number of seconds since that time, which I think is when the first Unix was made.
Okay.
Yeah, I'm not sure what time is. But false for Boolean, 0 for integers, 0 for floats, empty for strings, nil for pointers, functions, interfaces, slices, channels, and maps. Right. So if we wanted to see what the time was, godoc.org, and is it just time? And time is type time, and it's a struct. So a struct is not listed there. So we look at each of the individual fields in the struct, I guess.
Yeah.
Int 64 would be 0.0. That would be 0. Sorry, int 64 is 0, and this is 0. And then we'd have to look up location and figure out what that is, right?
So it looks like the way that Go stores time is slightly different from Unix time. So but yeah, it's the number of seconds elapsed since January 1st, year 1 at midnight UTC.
It's a pointer though, location's a pointer, so it's still a
Location,
null
yeah.
pointer or something.
Yeah, and then location's going to be nil.
Location.
It's a pointer to location, not a location itself.
Okay.
So it's going to be a nil.
Yeah, because it's just no address, right?
Yeah.
That makes sense. All right, you present. So how do the ancestors work? So there's often a relationship between one entity and another. For example, a user can have posts. The ancestor of a post is the user, right? Users have posts, users have descendants. One of their descendants might be posts. Could photos be a descendant of users, right? Like a user could have photos and that would be one of their descendants. So ancestor queries, we can query based upon ancestor. Give me all the photos that have this ancestor, right? What I'm saying is give me all the photos that belong to this user. So here it talks about ancestor paths. You guys want me to read it to you, or how many people? No? Doesn't help? You want to read it to yourself? See if it makes sense? The part that's interesting to me, a root entity and all of its descendants belong to the same entity group. So the root entity, right, and all of its descendants belong to the same entity group. I'm not sure what the implications of that are, but it makes me start to think that, there's, I don't know, I haven't quite figured out the connection between all that, but there's something about that which maybe becomes important.
Could be a performance thing. If you're looking stuff up based off of ancestors, it can go start from that basic ancestor and look down, depending on how it's implemented.
Getting records. So the way we can get records is we can pass a key and value pointer to datastore get. So that's one way we could do it. We just saw that right here. Key and value pointer to get. We could do a field query. Give me all of the employees who have the role manager. And we could do an ancestor query. Give me all the photos that have this particular ancestor. The query operates on entities of a given kind.
Performance-wise, if you've got the exact key, that's going to be the fastest to look up. After that, the ancestor query will be the next fastest, and then a field query where it has to look into each entity's properties for stuff is going to be the slowest.
So key is fastest, ancestor query is next fastest, and field is slowest. fields properties are indexed. So
That helps the speed a bit.
yeah. So here you see keys, properties, ancestors, and it talks about those 3 ways that you can get data out of the data store. You get it directly by their keys. An application can perform a query to retrieve them by the values of their properties. The query operates on entities of a given kind. It can specify filters on the entity properties, values, keys, and ancestors. So you could do filters on ancestors. And you could also specify sort order. Typical query includes the following: entity kind, to which the query applies, 0 or more filters based on the entity's property, values, keys, and ancestors, and 0 or more sort orders to sequence the results. When executed, the query retrieves all entities of the given kind that satisfy all of the given filters. To conserve memory and improve performance, the query should, whenever possible, specify a limit on the number of results returned.
Same as getting data from the user, except this case you can trust the data because you yourself put it in the data store, but you have no idea how much data you may have put in there in the past. So make sure you limit it down to a max size that you're interested in. You don't want to overload your server. Looking at every tweet on Twitter all at once would not be a good thing.
So the thing about ancestor queries is they are strongly consistent results, which are guaranteed to be up to date with the latest changes to the data. Non-ancestor queries, right, are eventually consistent, so they may return, not the absolutely most current results. And when Caleb talked about this, he said, so your results might be 800 milliseconds off, right?
Which is just enough when the user's refreshing the page after they've uploaded something.
Yeah, to make them mad. So believe the bird, not the book. So here's put, right? So that was like all the book, the theory, except for that one code sample. So here we have, we're doing a little program that's kind of a dictionary, and that has words and definitions. So we have struct, type word struct, and term and definition. And then if the request method is post, right, we're posting something. So up above, that's handling the index. And so we get the term from the form, HTML form, and we get the definition from the form, so user submitted a form. And then we get a context, and then we create a new incomplete key, we pass in the context, and we give, these are words, right? So this is like basically my kind is words. It's so hard for me to switch from table to saying kind. My kind is word, and nil. Nil is what normally goes here, or what might go there. What is that nil part of new incomplete key? I'm sorry, I told you my head's in 3rd gear. Yeah, I think it's Ancestor.
Yep.
Am I in the right spot even? Yeah, I am. So I'll make sure I was in data store. Key, new incomplete key. Yeah, that'd be the parent key right there. So then we, whoops, that happens. Then we do the entity, right? There we go. And term and definition are coming from what the user submitted. So we're putting that into a variable of type word and getting the address of that because that's what is required here. I actually, if I was to rewrite that, I'd put the ampersand right there. I think you should take it, the address, when you need it, not before. So context, and then we put it, context key, and the entity. And then the head, oh man. The header, we set the header. So we're saying this is text HTML, and we're writing to our response. Let's see, what do we have here? This is the form that they could add stuff. So we're not showing that anything got put in, but we just allow people to submit a form, and then we store it, and we're not giving them any feedback. We just show them the form again. And so I could come here and enter dog, mankind's best friend, and then I could go to localhost 8000, and I could click on datastore viewer, and I have an entry, right? And you can see definition, mankind's best friend, and dog. And this ID got created for me because I did new incomplete key, right? And I said, you create it for me. When you get this, you create the key, you know? And so there's the ID for it. And it's an entity kind word, right? So that's basically my table, right? It's in the word table. And so that's just looking at it a little bit closer. You can see the ID, right? And so then I thought that's what we just did, put new key. So I could also do it this way, where I have do new key instead of new incomplete key, and I'm passing in the term as the key. Because why not just use the word as the key? And then every time I update it, I'm updating it by the word, right? So same thing except for that part right there. And so cat, aloof and snotty. Sorry, this is an opinionated presentation. And now I have, and this shows like the schemaless nature of NoSQL, because I just changed my data structure while I was doing it. I didn't have to put in a primary key, right? In the sense of like SQL, where it's like, here's my key field, right? Like this is the key for this one, and here's the key for that one. I'm just storing all that together, and it's up to me to make sure that I know how to, you know, access it and make sense of it and use it, right? I'm not putting that on Oracle or Microsoft SQL Server or totally in neutral. What's the open source? MySQL. There we go, right? So that's up to me. And so now I have the key cat. So this was created with new key. This was created with new incomplete key, right? And I've stored that in there. And you can see that this way too by clicking on it. And so then when I change this, fuzzy and warm, do well when left alone. I decided that first definition was a little bit too harsh. And so here is changed it in the data store when I updated that, right? Just set the form, hit submit. Okay, cool, change the entry. Updated it, so that's the key that got passed in was cat, right? So use new key when a unique key is obvious. All right, email is the key for a user, right? Something that's unique, or the word for a dictionary. New incomplete key is a random int ID, like for photos, right? You could just do a new incomplete key. And then we have get. So how do we get stuff out? So if the path is not equal to this, we're going to split the path up. And splitting path up means like, you know, so localhost 8080 prints out all the words. That's what we wanted to do. And well, I should have an example where it prints out one word, but I don't. Let's run it. Datastore 0203. There we go. And I go into localhost 8000. And I can see datastore viewer, profile word.
List entities.
List entities, thank you. And I can see the different words there. So that's what's coming out here. So I could add another one. It's an animal, pig. Yummy to eat. And didn't refresh. If I come over here and I now have pig, yummy to eat. And if I refresh this page, pig, yummy to eat. And I wonder if I type it, do this, pig, cool. And it just gave me that one word and definition.
That would be a RESTful API.
And why RESTful? What's that mean to you, my friend?
It's the what it's doing is dependent upon the URL, but it's not a hard-coded URL. You don't have a particular, in the code, a URL/pig as one of your routes. You just have slash, but then the slash looks at the path and does something different depending on what that path is.
I think of RESTful like this doesn't go to a specific file. I'm not saying your definition is wrong at all. I think your definition is great. But another way that you could look at it is, your URL, the structure of your URL has meaning, and like if I wanted to see pigs' photos, right? I'm now looking at sort of in a hierarchical way. Hey, this pig has these photos, right? It could be photo 1, photo 2, photo 3, or this word has these photos. That'd be a better way to think about it, right? Because this is the word, and then this would be things after it. And none of this corresponds to files on the server, but it's just the code getting executed.
So I believe also when you posted that pig thing, it didn't update the definitions list. Pig wasn't there yet. That is because the data store's got the eventual consistency. So you may have sent the signal to save pig, but it takes a couple seconds for it to actually get fully saved. So when you immediately then accessed it to get all the definitions to display them, pig hadn't been fully saved yet. You got a little bit stale data.
So that's what that first part does there is, we're looking at the URL path, and if it's not just equal to the /, because the URL path will give me where'd my pig page go? URL path will give me everything there forward. Okay, so this is the domain. This is the URL path. And so if it's not just equal to that, I want to figure out what this word is. So I'm going to break it up and split that string up, the string which is this, right? Right, I could split it up by breaking it up on these. And then each of these would become a slice of strings, and this would be at, right there would be index position 0, index position 1, index position 2, 3, 4. Does that make sense? So I could get at each of those pieces. And so when I get at each of those pieces, right, I'm going to split up the request URL path. I'm going to break it up by those slashes and give me the thing at position 1, which would be pig, right? And so show word, response, request, term. And then I have a function show word to show that. And we should just be looking at this in WebStorm. And then that will show the word, right? And so if the request method is post, then I want to save the word. And then I want to list all the words. Okay? So everything goes through here, and then that all goes to handle words. And handle words is right there, where I could break up on words. If it's more than that, I assume the person wants to see just that one word, and then I do show words. And show words is right here. And show words will go get that word. So how does that happen? New key, right? And context, and then kind, and then the term. So I'm looking up the word pig here. So term got passed in, and term comes from right here. I got the term because that's the thing from the URL, and then I passed it into this function I created, and I'm all proud of that. I created it, and new key, and so that's the term, and then this is 0 because the term, when you use new key instead of new incomplete key, you have to either give it a string or an int. Like which way are you creating it? I'm creating with a string, so that's why this is 0. And then nil here is there's no ancestor.
How would we handle the entity that we put in where the term wasn't the key?
So if the term wasn't the key and you had some other kind, because for this kind I'm going to...
With the new incomplete key during your earlier example.
There's the shorter answer.
Yeah, you typically use a value query. You query over the value of the property term.
Wait, so your question is how do you create the key, and then how do you get the stuff back out if you?
Well, I'm saying I don't. The first word that we added to the site, I don't think we can pull it with this one.
Oh yeah, that's right, huh?
The dog, yeah.
Yeah, because that's a really good point. So Corey's point is this first word, dog, I need to get it with that. I don't have anything here, so it's not going to get dog. So if I go here and try to get dog, that's not the key. We're all going to be like, if that actually brought it up, we'd be like, okay, we got to rethink this. Right? Like that doesn't bring it up. But I wonder if I brought this over.
No, because you're putting it in the wrong spot on the.
Yeah, I think so.
In the-
That's not going to do it either.
But we could use a query to get the key.
So
Yeah, so how do
yeah,
we...
a query would get that if your code was going through a query.
Yeah, so we could... that's
Yeah,
great.
you could do a property query on the value of the term property.
Cool.
So, but as I said before, though, the value queries are the slowest. And if you've already configured out the key yourself, like if you design the key so it's that term, then that's going to be a lot faster.
So here we're getting context, key, and the entity. I like right the way I did that here, where I take the address just right when I need it. I don't know if anybody has any thoughts on that, but and so if there's no such entry, then we say not found. If there's an error, just some other general error, then we just return an error. Otherwise, we set the type, content type, text HTML, and here's just a partial web page, right? It fills in all the other stuff for you, so you don't have to do all the full web page. You could just do, and right, it filled in all this other stuff for me. That's all I sent right there. I can't do that. But it filled in all that stuff for me. So browsers are pretty forgiving. And so that's show word. And then here we have save word. So if it's post, the method coming in is post. Like how cool is this, right? Like, I mean, this is pretty good stuff. We're like, doing RESTful. We're breaking up the URL. Our URL means something. It goes and runs a function, returns a response, right? If the different verb coming in, if it's post, we're checking that, okay. In which case, we'll do something else. We'll save the word.
This would be a good point to use Julian Schmidt's router.
Yeah,
So
that's coming up.
With the serve mux, you have to do that manual, almost splitter function to split between the three different actual options.
Yeah.
With Julian Schmidt's router, you can just have the router itself deal with that.
Right there. So here's how you do it with Julian Schmidt's router. So instead of like breaking, having to parse the string, the URL, right? You could just say, okay, hey, here's the value I want to get at. And you could do get, or you could do post, like post is coming in, then run this other chunk of code right here. So Julian Schmidt's router has some of that built in. A lot of people seem to like it. So saving the word, form value term. So we're getting this from the form, right? So the form value, the term and the definition, then context, and then create a new key, and create an entity. Be consistent. And then put it, and then redirect back to the default page. So this is what I want to do. What are you guys' thoughts? First of all, we are leaving off on, I think right there, right? Yeah, can't put, 33. Today's Tuesday. So on Thursday, I want you all to, I'll put an assignment up, and I want you to do the assignment, and you'll submit, how do we get it running? Well, you could put it on App Engine, so you could deploy it to App Engine, right? And then when you're on App Engine, you guys are like, oh crap, this sounds like an assignment. When you're on App Engine, your app can be running at this URL, so your app ID. So I want you to submit this URL as, here's the my completed homework, and I want you to create something in using App Engine and datastore, and then deploy it up to App Engine, so that on Thursday when we come to class, I'll have a list of URLs, and we can just open each of them up and see what you guys created. So it could be as simple as this deal right here, or it's just some sort of a dictionary, but instead of a dictionary, you called it items in the kitchen or something, and you can look up whatever, right? But create something.
So by next Tuesday, that would be the weekend.
You guys want to push it till Tuesday for the weekend? Yeah. How many people need the weekend? All right,
got
fine.
midterms.
You got the weekend.
There's bound to be problems.
Yeah, when you first start working with it, ironing out the kinks. But I'm pretty excited about this. I'm sure you could see that reflected in my demeanor. No, but it's finally it's like, whoa, this is like the meat and potatoes. This is like you can actually start doing something. Like you are now able to get data, store data, display data, create, read, update, delete records, right? And that's it. That's when you've got that. That's like the holy grail. Like you could do so many amazing things and start building things up. So we're just going to keep building on this. We have a little Ajax coming up. We'll look at how to integrate JavaScript and do Ajax asynchronous stuff. Yeah, it's coming along. This is a really specific skill. It's a skill that not a lot of people have, right? To be able to do this. How many people feel the same excitement I'm feeling? I don't know why I'm coming off so flat. That's kind of cool, right? Like that's kind of cool. And then you get your domain, and it's out there, and you're building something. So we're getting pretty close. Sorry, my brain was somewhat in neutral today. Wasn't quite as awesome of a presentation. It's hard having a lot of demands in life. Challenging to get them all done. See you all Thursday. So you have the weekend to do that. I'll put that up on Blackboard, the assignment.